All right, let's talk about something truly amazing. Inside you, right this second, there's this non-stop delivery service. I'm talking 24/7, no holidays, no breaks. It's the ultimate lifeline, and we call it the circulatory system.
But let's bring this home for a second. Think about the last time you ran for a bus, or maybe just took the stairs instead of the elevator. You feel it, right? That boom, boom, boom in your chest. What is that really?
Well, that pounding in your chest, that's your circulatory system kicking into high gear. Your muscles are basically yelling, hey, we need more oxygen down here. And your heart, well, it responds instantly. It starts pumping like crazy to rush that fuel exactly where it needs to go. It's the system responding in real time. So yeah, that thumping, that's your pulse. And it's more than just a feeling. It's the actual rhythm of this incredible internal network. It really is the pulse of life.
So, what's its job description? It's actually pretty straightforward. It's got two main gigs. Job number one, deliver the good stuff. We're talking oxygen, nutrients, to literally every single cell in your body. And job number two, it's the trash collector, picking up all the waste products and hauling them away. Okay, to really wrap our heads around this, it helps to break it down into three simple parts. Think of it like this. You've got the highway, the pump, and the cargo. First up, you've got the highways. This is this massive, intricate network of blood vessels. We're talking arteries, veins, capillaries, a whole road system that stretches to every single part of you, even the tiniest, most remote corners. And every highway system needs an engine, right? That's the pump. And you guessed it, it's your heart. It's this incredibly powerful muscle at the center of everything, just squeezing, relaxing, pushing that blood through all those highways, nonstop.
And finally, what's actually moving on these highways? The cargo. That's your blood. It's the fluid that's carrying all the essentials. The oxygen, the nutrients, hormones, you name it. It's the precious cargo that keeps everything running. Now, you might think blood is just, well, red liquid. But it's so much more complex than that. If you were to take a vial of it and spin it down in a centrifuge, you'd see it's actually made of a few different, very distinct parts. Check this out. A little over half of your blood is this yellowish stuff called plasma. Then about 45% is what we all think of, the red blood cells. These are the guys carrying the oxygen. And that tiny little sliver left over, less than 1%, that's your white blood cells and platelets, your body's little emergency response team for fighting infections and stopping bleeding. Okay, so we know the players. Now for the fun part. Let's actually follow a single red blood cell on its incredible journey. Think of it as a day in the life. It's a wild ride. So where does our little red blood cell's trip begin and end? Right here in the heart. This is home base. You can think of it like a 4-room house. The 2 rooms on top, the atria, are like the entryways where blood arrives. And the 2 powerful rooms on the bottom, the ventricles, are like the launch pads that pump the blood out with force. Now, our little cell doesn't just go on one big loop. It actually has 2 major routes. The first trip is a quick one. It's called the pulmonary circuit. Its whole mission, get to the lungs, grab some oxygen, and get back. The second trip is the big one, the systemic circuit. This is the cross-country road trip to deliver that oxygen to the entire body. All right, let's go. Our cell has just finished a delivery, so it's running low on oxygen. It pulls into the heart's receiving dock on the right side, the right atrium. From there, it drops down into the right ventricle, which, whoosh, pumps it straight out to the lungs to pick up a fresh supply. That's the whole pulmonary circuit right there. Okay, oxygen tank full. Our cell zips back to the heart, but this time it enters on the left side, into the left atrium. It drops into the left ventricle, and this is the powerhouse of the heart. With one enormous squeeze, it launches our cell into the aorta, the main superhighway of the entire system. The big delivery run has begun. So our cell is flying down these arteries, these major freeways. They keep branching off into smaller and smaller roads, like city streets, until finally, they become these tiny little alleyways called capillaries. They're so small, cells have to go single file. And this is the drop-off point. Right here, our cell hands off its precious oxygen to the tissues that need it. Mission accomplished. Now it's time to head back to base. Our cell, now oxygen poor, starts its return trip through the veins. But wait a second. How does blood get from your toes all the way back up to your heart without falling back down? It's genius, really. The veins have these tiny little one-way gates or valves. Blood goes up, the gate opens. If it tries to fall back, slam, the gate shuts. Pretty cool, right?
And get this, that entire round trip, it takes about a minute. That's it. It's a beautifully efficient system. But it's built on the idea of keeping that traffic flowing. So what happens when you get a traffic jam? Well, one of the biggest issues is what's called hypertension. You probably know it as high blood pressure. In our analogy, this is like a major pressure buildup on the highways. The pump, your heart, has to work way, way harder just to push the blood through. And often, what's making it work so hard is something called arteriosclerosis. This is when the highways themselves start to get stiff and narrow. Imagine a 4-lane superhighway suddenly getting squeezed down to 1 lane during rush hour. It's a recipe for a massive jam, and it puts an incredible strain on the heart. And when that traffic gets all jammed up, it's not just inefficient, it's dangerous. You can get blood clots forming. And if one of those clots breaks loose, well, if it gets stuck in the heart, that's a heart attack. If it gets stuck in the brain, that's a stroke. So yeah, keeping the traffic flowing smoothly is absolutely critical. Just to give you a sense of how hard this system works for you, think about this number. 2.5 billion. That's about how many times your heart is going to beat in an average lifetime. I mean, just let that sink in. That is an unbelievable amount of work. So you have this incredible system inside you, working tirelessly, second by second, just to keep you going, which really just leaves one last question, and it's for you. Knowing all this, how are you going to take care of your lifeline?